everyone for attending. Can you hear me? Yeah. So my name is Chandan Reddy. I'm a professor of computer science at Virginia Tech. I'm also an Amazon scholar. And so this is a joint work with several Amazon researchers. None of them could be here due to visa and several other reasons. So I'm going to present our work on their behalf, right? So today what we are going to talk about is on quantifying fairness in LLM responses, particularly long form responses, right? So what are we trying to identify? Here is the semantic differences between responses when some of the demographic attributes change, right? So when we have Jackie on the right-hand side, when we have some background information and we are recommending, we are trying to suggest what will be the next step in their career, Jack seems to be very, he can thrive in that career, whereas Jackie, when we change the name to a female name, might be finding that field as challenging. So given the same information, when we change from male to female, whether the LLM responses tend to change their tone or the way in which they say things, right? So of course, this is not a new problem, but in the way in which we are doing for long form responses, when we have a paragraph response for male or female or for any demographic attribute for different age groups, different race attributes. So we are trying to identify these differences that are subtle, not necessarily at the word level, not at a token level, not even at the embedding level, but some of them are really subtle when you take individual responses, right? So that is what we are trying to look for. And one thing to note is that these are all valid responses, right? So there's nothing like a right or wrong. It's just, it's a valid response, but then when we accumulate them across the entire demographic group, that's when the problem starts becoming more explicit, right? So then it becomes very clear, right? So to tackle this problem, we are going to introduce this framework called FiSCo, right? Fine-grained semantic comparison. So before I talk about the framework, I want to just put it into perspective, some of the work that has been done in the literature in fairness and other deep learning or LLM communities, right? So one thing very popular these days is reasoning, right? So in reasoning, we have this math, logic, all this, the coding problems where we have a single correct answer, right? So when we talk about language, fairness, ethics, all these bias issues, there's no real one correct answer, right? So there might be multiple valid answers. So that's one big difference, because then we don't have the ground truth. We don't even know what to optimize for, right? And again, these differences can happen at the distribution level, so not necessarily at the individual level itself, right? So that's another challenge that we are going to face, right? So essentially, our goal is to identify whether the model has treated different groups in fairly, right? So that's the main goal here. And then we have to also include the fact that the LLM responses can be stochastic in nature, which means because some of these writing assistants, it can be really probabilistic, LLM probabilistic output, and we want to make it creative. The temperature is high, so the variation might not necessarily because of Jack and Jackie, but maybe if Jack is asked the second time, he might have the similar response to that Jackie had, right? So we also want to attribute if this variation that's happening in the responses, is it because of the bias in the protected attributes, or is it in general because of the stochasticity of the LLM outcomes? So that attribution is what we are trying to go after in this work. And so that is one key problem. To identify that, I mean, that's not a very trivial problem to solve, because we need a controlled environment which will take care of the confounding variables or impact in the prompts that we create, as well as we want to make sure we have a reliable measurement mechanism. Right? In the fairness literature, there are two bodies of works. Right? One is the group fairness, which is usually done for several years. It has been there for almost 8 to 10 years now, which basically is going to say if an ML model is built for any for career advice or hiring decisions, for medical decisions, right? So for all of them, I mean, you want to make sure that the model is fairly accurate across the board, right? So across male versus female, different race groups, different age groups, the model has to do decently well, right? Similarly, right? You cannot have 95% for one group and 70% in the other group. Then, so that level of fairness, the group level fairness has been done, but mostly it's in the numerical representation. So when the accuracy or F1 measure, which is a numeric entity, is where the comparisons has been done, right? The other body of work is what is called as counterfactual inference, counterfactual invariance, where we would try to infer if the response will be different when the name is changed, right? So when Jack becomes Jackie, if the response is changed, but then the way in which the similarity is computed or the sentence itself is not long form, and most importantly, is the variation occurring because of the name change, or is it because of the stochasticity of the LLM, right? So combining all these issues, what we are proposing is a group counterfactual fairness, which will take into account the distributional difference between a particular demographic group versus the other group that is that we are comparing against. So in this example over here, we are looking at similar background and performance, and we are trying to compare female employees and male employees and asking LLM to provide reviews, and we look at the distribution of the reviews for both these groups and trying to identify at the distributional level whether there are differences in which in the way in which the LLMs have generated the reviews, right? And of course, we want to look at a fine-grained semantic meaning as opposed to just at a coarse embedding representations. And so we are going to decompose this into claim level, which is an atomic unit that we are going to use for doing this comparison, is the lowest possible unit that we can think of when we are trying to do the comparison, right? And more importantly, because we are looking at the groups, we are also looking at is the variations across the groups, which we call it as intergroup, and we also compare within the group, which is intra-group, right? So we are looking at the within group variations as our baseline, so that we are looking at the variations between the groups and comparing within the group to see if we can really attribute this to the differences in the in the particular demographic protected group, right? So essentially, we are trying to combine the group fairness concept of looking at the distributional variance with respect to the counterfactual invariance thing that I mentioned. So that is at a high level what we are trying to do. And where do we stand in the bias benchmark? So of course, the bias, there have been so many other works, benchmarks that are that have been there. And so where we stand with FiSCo is the fact that it supports long-form responses, not any short-form or scalar entities, and open-ended responses, and being in doing the analysis at a claim level, which is a very fine-grained unit. And so this is where we distinguish ourselves, and the benchmark is available on the paper website. Okay. Okay, so now what do we do, right? So what is this FiSCo, what are we trying to do? The overall overarching idea is relatively simple. We have like 3 components that are going that we are building for achieving this goal. One is the control generation. We start with some base prompts, which are related to generate insights from the collections that we have, or we are seeking some advice, and we have some of these base prompts, and we trigger the protected attribute, again, male, female versus different races, different age groups, and so on. And then we look at LLM responses. So we collect all these responses, and that's where we do the second step, and let's do the semantic comparison of these responses. To do that, I mean, one can do sentence level embeddings, one can do word level, word movers distance, and several other representations. What we are leveraging is some of the recent work on claims. So given a response, which is typically a paragraph, we are looking at what are the atomic units, what are the claims that this response is making, and we compare the list of claims from one response to the other response, right? So, and then these claims can be, when we compare, either it can be an entailment, or it can be a contradiction, or they can be independent of each other, in which case we call it as neutral. Depending on how many claims are entailed and how many are neutral, we will give a score. And so 2 paragraphs now will have a similarity score that we would want to, that will measure how close these responses are semantically. Right? Once we have that similarity computation done, we do that at intra-group level and intergroup level, and we compare it, and we do the t-test and statistical significance, and determine if these are 2 different groups or distributions, are 2 significantly different distributions, are they the same, right? One thing to note, that we are not claiming anything to do with causal factors, basically meaning why is it doing what it's doing. So we are not talking about that. And also we are not even saying that maybe a minority group has a disadvantage response, right? That's not what we are trying to do. At a global scale, are we trying, can we see, even though individual subtle differences might not be triggered by a single, the LLM as judge as a biased response, overall, when we have hundreds of responses for a particular demographic group compared to the other group, do we see this distributional difference? So that is where we are heading towards, okay? And so we do the claim level analysis, and basically we say entailment when we have, so here is a prompt where DeepSeek is, is providing the response. When we have the similar, the yellow ones are the entailments, which basically are the same response, so we give a higher score for similarity. And then the green ones over here are neutral independent entities, so we give half of the score, not the highest score. And the purple ones are the contradictory ones, where the male group was recommended to go for top MBA programs, and the female group was recommended to do a local program with part-time options, right? So that is where the contradiction. The more contradictions you see, the lesser the similarity score, and we penalize that when we do the distributional similarity comparisons, okay? And again, we do it male to male, female to female, and then compare it with male to female as to see the difference, right? So now, to just in the interest of time, I will just quickly go over some of these results. So firstly, we have to make sure our similarity score has really useful meaning, right? So if you see on the right-hand side, the case for semantically similar text, where the responses are semantically similar, and so we want this score to be higher. So if you see FiSCo, it has a very high score, which is good, and even BERT score has a very high score in this case, right? Whereas on the bottom, you see that semantically different text, where a software engineer is being asked to pursue a master's degree in computer science, whereas a mechanical engineer is asked for pursuing a master's in engineering management. These are very different things, and some model like a BERT score is going to give 0.95, very high score, whereas FiSCo is going to give a very low score, because we are looking at dividing it to individual units. And so the similarity function, what we are trying to use, has a lot more nuanced representations internally that we can leverage to build our similarity computation, right? And the other thing to note is that we also did a lot of synthetic generations where we have a controlled environment to know the ground truth. And we have done actual LLM responses and the human, because it's paragraph, I mean, human also has a difficulty in trying to find, if you have a reference text and you have text from a male and a female, I mean, trying to compare which one is similar, it's not a trivial problem when we have paragraphs to look at, right? So we did do the comparison, and we show that this similarity evaluation outperforms other methods that we have investigated, right? The other methods that do group level fairness to a certain extent are the fair pair and using the semantics, the n-gram, toxic words, and so on and so forth, sentiment representation. So there are different ways in which one we're studying, but then what we show is FiSCo can clearly distinguish when the ground truth has these variations, the ground truth has these distributional differences. One FiSCo model can really get that in TSNE plot. You can see the representations are clearly separated when the ground truth really has these differences. And we do compare with whether it agrees with the human representations or not, right? Again, once we are confident that the FiSCo has a potential for doing the distributional difference, we can also do this across different models, right? Starting from basic open source models like Llama 3 to the more standard models, GPT-3, 3.5, GPT-4, and the Claude 3, and more recent reasoning models as well, DeepSeek. And what we observed is some of the open source models you have very high, these are the numbers I'm showing are the percentage of the prompts which had distributional difference in their responses. And so we can do it at scale now, right? Once we have this framework set up that we can do across the models and identify which models are sensitive to or are providing these biased responses at the distribution level, right? And one thing to note is that reasoning models don't mean because of their overthinking or something happening inside the reasoning model, it doesn't mean that they do outperform these other non-reasoning models for this particular task. And we are surprised that GPT-OSS has, the recent GPT had a very high score, and we are still investigating why that's the case, okay? So those are the three main components: similarity computation, and then the group level fairness evaluation, and then benchmarking across different models are our three main results. And so the key takeaway is that we have a claim level semantic fairness measure now that we can do the large language model outputs, and these are not, the claims are more powerful than representations that involve tokens, embedding, sentiments, all these representations that we were using for determining the distributional fairness before. And FiSCo, the way we see it is that bridges the gap between traditional fairness metrics and the open-ended reasoning task where multiple valid answers do exist. And we remember this with S cube, which S for semantic because it's grounded in meaning, and statistical, it measures the significance as opposed to just thresholding, and scalable, it can do it across different models and their responses. Right? And to summarize, our contributions are to formalize the group counterfactual fairness for open-ended generations, and in terms of statistical measurements for inter and intra-group similarity to mitigate the stochastic effects of the large language model outcomes. And then finally, we are going to release we already released this fairness benchmark across 3 different groups, gender, race, and age groups, and the code and data are available in this link. And our poster is 44 right after this session, so please do stop by if you're interested in the topic or if you want to chat about any of the fairness. And thank you for listening, and I'm happy to take any questions now.